continue with a few more miscellaneous topics. The first type of question we will see is we will sometimes have to write fractions as decimals. Now there is a process to do this by hand, but I generally recommend just typing that into your calculator as a division problem and taking what the calculator gives you. So here I've got 2.4375. Anytime we have to compare a fraction and a decimal, as we do in the next one, I would go ahead and first rewrite that fraction as a decimal. So 17/3, that is 5.6 repeating. So this one is technically a little bit bigger, just because we round it sooner. So the alligator points in the direction of whichever one is larger. So we will see a handful of questions like that. All right, let's now look at some basic exponent rules. If I'm multiplying together two x's, then what I'm going to do to combine them is add their exponents. And you'll notice we don't put a 2 in front of that. We are just adding the exponents. So y to the 4th times y squared, they both have a y. So I'm going to go ahead and do this rule. So I am just adding those exponents. And so I get y to the 6th. The next one, I've got 3 terms, but they're all w's. So that means I'm going to add up all of those exponents. So 4 plus 9 plus 6 gets me, whoops, that's 19, not 16. There we go, 19. So w to the 19. So that is called the product rule for exponents. We also have the quotient rule. So now I'm dividing, you'll notice again, these are still x's, and now we're subtracting the numerators, the exponents. We have to be just a little careful. It's always the numerator exponent minus the denominator exponent, because the order matters with subtraction. Now we need to remember one more thing here for number 23. If there's no exponent written down, we do understand that to be a 1. So those d's are the same, and I'm dividing, so that means I'm going to subtract those exponents. So here I get d to the power of 8. Similarly, the next one, they are divided, so I am subtracting those exponents. 7 minus 6 is 1. And remember, if we get a 1 exponent, as mathematicians, we're very lazy, so we generally don't bother to write it down. That has an understood 1 on it. So that is our quotient rule for exponents. You might have seen in other math classes that there are other exponent rules as well. We are not going to worry about them for this class. Those are the only ones we need to know. We will also, though, need to know how to simplify a radical. And just to help you out, I've got a few of our basic squares. So the top line there is the initial number. The next is the squared. So for example, 8 squared is 64. Obviously, there are more perfect squares than that, but that's generally about as high as we're going to need to go. So when we simplify a radical, if you type the square root of 180 into your calculator, you get a horrible decimal. It's not a nice number. I get about 13.416, etc. So while I can't ever get a nice number, I can simplify that. What I want to know is 180, is that divisible by any of these perfect squares? And generally the way I do that is I start dividing it by some of them. It's not divisible by 4, but it is divisible by 9. So I'm going to rewrite this as 9 times 20. And I've still got it underneath the radical. Now 9 is a perfect square. The square root is 3. If you have two numbers multiplied under a radical like that, we can write it as each number individually underneath the radical still multiplied. Do note you cannot do that if numbers are added or subtracted, but we can do it for multiplication. Now you'll notice I always put the perfect square first, and that's because it's a reminder to myself this is the number that I'm going to be able to simplify. That's the perfect square, and I can take that square root. So the square root sign isn't there anymore because I did that operation. Now the square root of 20, can I simplify that? Well, yes, I can. That's divisible by 4. So I need to keep going. 20, well, that's 4 times 5. So I can do the same process. The square root of 4 is 2. And last but not least, I'm going to multiply those two numbers out in front and get 6 root 5. We would consider this the fully simplified radical. So be careful, 3 root 20, I started simplifying it, but I didn't simplify it as far as I could go, so I had to keep going. And that's what we mean by simplifying a radical. Let's try another one. I've got the square root of 117. Again, this is what our calculator is for, because most of us don't necessarily know what multiplies up to that. But 117, as it turns out, that is 9 times 13. So again, once I get that, I'm going to write it as two radicals. And then let's take that square root. So I get 3 times the square root of 13. Nothing multiplies into 13 except 1 and itself. So that is as far as I can go. Now what about 21? This is where students have trouble, because things do multiply up into 21. That's 3 times 7. But 3 is not a perfect square. 7 is not a perfect square. The only numbers I care about are the perfect squares. So 4, 9, 16, and so on. That's not divisible by 4. It's not divisible by 9. It's not divisible by 16. And everything else is bigger than that. So we would say that root 21 cannot be simplified. That's as nice as that's going to get. And we will still sometimes see answers like that. So don't panic. That will happen. That is the answer we're looking for.